Alright folks, hello and welcome to this video example. In this video we're going to be looking at number 2 of the take-home quiz, and I'm going to be walking you through an example of how to write a quadratic function in standard form and change it into vertex form. Here is my quadratic function that I chose. You cannot use these numbers. Okay, so when you make your quadratic function, make sure at least 2 of the numbers are different because you have to make up your own. I even give you a hint of how to make it a little bit easier, but these numbers will do for our purposes. So in order to change it into vertex form, we're going to use the method of completing the square. There are other ways to do this, and you're welcome to look into those if you want to research on your own. We're going to use completing the square as a way of changing this into vertex form. Sorry about that, a little messy there. There we go, completing the square. First thing I want you to do is let's drop the y for a moment and just set it equal to 0. Previously, when we completed the square, we always had one variable x, and I want to use that same idea. Later on, we'll put back the y where the 0 is, and then we'll have our quadratic function. And then we're just going to follow the steps of completing the square. First, we want to isolate the constant. So I'm going to subtract 10 from both sides, and we get negative 10 equals 3x squared minus 9x. Isolate the constant. Now, our rules, when we wrote them down, were isolate the constant on the right-hand side. So let's switch this equation around and put the negative 10 on the right-hand side. I left a space there, but we don't need to fill that yet, because next we need to make sure we have a coefficient of 1. So since there's a 3 there, we're going to factor out a 3, and then we get x squared minus 3x equals negative 10. Again, strategically pick your numbers. Notice how it was nice and easy for me to factor out a 3 from both of those terms. That might influence your choices for your first 2 coefficients. Moving on. Next, it's time to add the blanks. In order to complete the square, we want to add something that makes this polynomial factorable and a perfect square. Plus blank equals negative 10. Whatever you add to one side, you add to the other, plus blank. In this blank, we use the rule of doing b over 2 squared, or the middle term divided by 2 squared. In this case, it is negative 3 divided by 2 squared, which will actually give us 9/4. So in the blank, using that rule we just did, negative 3 over 2 squared, we know that there has to be a 9/4 in this blank, which means we have to multiply by 3 to see what goes in this blank here. Remember, what we really added to the left-hand side was 3 times 9/4, and I want to give some credit to Amanda Post for pointing this out in an email. So we need to multiply by 3, and what we add to the right-hand side is 27 over 4. Then when we factor, we want to factor this inner expression, we end up with x minus 3 over 2 squared. And then on the right-hand side, we have equals negative 10 plus 27 over 4. And we can simplify that. Actually, you need a common denominator, so it will be negative 40 over 4 plus 27 over 4. That's just from multiplying by 4 over 4 to the negative 10. We could simplify a little bit further. We get x minus 3 over 2 squared equals, and this comes out to negative 13 over 4. Now, normally, we now take the time to solve by taking square roots. Isolate the squared term, take square roots. But we don't want that. We want it to look like vertex form. What's vertex form? I'll write it up here at the top. We want our equation to look like this. X minus a number squared, plus k, a is in front, and y is on the other side. So I'm going to add the 13/4 to the other side. I'll add 13/4 to both sides, and that will lead to 3 times x minus 3/2 squared plus 13/4 equals 0. And then just don't forget that our y was replaced with 0 here. So we'll do the same thing over here. This will become now our y, and we'll have our vertex form equation. The function will be, let's write it over here in the bottom, y equals, and I'm just going to change it into decimals, because when you plot this on a graph, it'll be easiest to use decimals. x minus 1.5 squared, and then plus 3.25. And that would be the acceptable vertex form equation. Again, I stress to you, it will be a wise idea to choose some nice numbers. I gave a hint on that, and you won't end up as many fractions as I did. Thanks for watching this video example.